Decentralized blockchains, like Ethereum, offer security and trust, but they struggle with scalability. Since every transaction has to be processed and computed by all validators, this is expensive and leads to high fees. And this is where rollups come in. They process transactions of L1 off-chain on their own layer 2 network and only submit a summary, the core data, to layer 1. This offloads the bulk of computation and data, but preserves essential information and results on layer 1. Once the summary is confirmed on layer 1, the rollup inherits layer 1's robust security. In the rollup architecture, a sequencer orders the transactions and writes a compressed summary to L1. It's essentially a notice board of all the layer 2 transactions because layer 1 doesn't execute them. The state proposer then updates L1 with the state resulting from all the transactions, informing the L1 applications about the current L2 state. The way the state is posted and its structure varies between ZK and optimistic rollups.